Okay, I'm ready.
Okay.
Okay, so this is your chapter checkup for science. And you're going to tell me everything you know about all these subjects. Yes. Okay. So what's the first one?
Basic types of energy.
Okay.
1. Kinetic energy. Kinetic energy is when something is only being used or made. Well, I don't know exactly. Well, so
Kinetic energy is when
the thing is moving.
something's moving. Okay.
Yeah.
And what's different than the next thing?
Potential energy is if, like, let's say there's a conveyor belt,
Uh-huh.
and then at the end there's a box,
Okay.
and there's like a little wooden block on it.
Okay.
The block on the conveyor belt has potential energy because when it gets to the end, it turns into kinetic energy and it falls.
Okay.
Yeah.
Is the block in motion on the belt though?
Yeah.
So it still has kinetic energy,
It
right?
still does.
What's something that would have just potential?
Like, say, like a book on the edge of a bookshelf.
Yeah.
Like, if the bookshelf gets bumped a little bit,
Uh-huh.
it might fall,
Uh-huh.
and it'll turn from potential energy into kinetic energy.
Okay. So potential, it's not moving, but it's probably going to?
Yeah.
Okay.
And yeah, that's that one.
Okay. What's the next one?
The strokes of a gasoline engine.
Okay. Tell me about a gasoline engine.
Yeah, so the first stroke is the intake stroke, where the little plug gets pulled out and the gas and stuff gets put into the engine.
Mm-hmm.
And then
What shape is the thing that the plug is in?
what exactly do you mean?
The plug is inside of something else to make a closed system. Do you know what it's called?
A cylinder?
Yes,
Yeah.
because that's what shape it is.
Yeah. And when it opens, it lets the gas into the engine part.
Right.
Yeah. And then the next stroke, that little plug closes and I think it compresses the gas into stuff.
Okay, and what's this called?
The compression stroke.
Okay, so we have intake and then compression.
And then after that is the power, where there's a little thing on the top
Mm-hmm.
that shoots a couple sparks out
Mm-hmm.
in this stroke,
Mhm.
which lights the gas on fire,
Okay.
which pushes the thing that squished it down back out.
Okay. And what's that one called?
The power stroke.
Okay.
And then the last one is called the exhaust stroke,
Uh-huh.
where the old gas that got burned gets put out by another plug that unplugs in a cylinder,
Okay.
and it goes to the pipe at the
Gets
back
rid of the
car.
extra stuff, right?
Yeah,
Okay.
gets rid of the extra.
Mm-hmm. So when the spark plug ignites the pressurized gas, that's what makes the power.
Yeah.
Okay. Okay, what's the next thing?
Types of consumption engines.
Okay.
There's the external combustion engine,
Uh-huh.
where I think it's like the steam engine,
Mm-hmm.
where this is the engine right around here,
Okay.
but where it's being the consumption of the fuel and stuff is here
Okay.
to boil the water to turn into steam to make the engine move.
Okay.
An internal consumption engine is like the gasoline engine, which I just told you about.
Okay. So the word is combustion.
Combustion.
external combustion engine and internal combustion engine.
Yeah.
And you know what the word combustion means?
Like burning?
Yes.
Yeah.
So the one you just described, you're right. The burning is somewhere else outside of the engine, external.
Yeah.
Yeah. Okay.
Yeah. Okay.
Okay. What's the next thing?
These important temperatures.
Uh-huh.
The first one is 32 degrees Fahrenheit,
Okay.
where water freezes,
Uh-huh.
and if it gets below then, or at it, but if it gets above that, it melts,
Okay.
like only a tiny bit above.
Okay.
And
And in scientific words, if you're going to use states of matter, solid, liquid, and gas,
yeah,
what can you describe it in those words?
it would turn from a liquid frozen into a solid,
Okay.
then melted into a liquid from
Okay.
a solid.
Okay, great.
2 is 212 degrees Fahrenheit, where water liquid turns into gas.
Mm-hmm. Do all liquids turn into gas at that temperature?
No,
No. Just what?
just water.
Yeah. So it's important because why? Why is water important?
Because just why water is important is because like everything needs it to survive.
Mm-hmm.
Yeah.
It's very common.
And so it turns from a gas from a liquid then, and it condenses from a gas into a liquid
Okay.
at that temperature.
Okay, if it's going down below. Okay.
Yeah.
What's the next thing?
Forces in nature.
Okay.
1, gravity,
Mm-hmm.
where it pulls you down, so you don't just float away.
Okay.
Contact force is when like something is sliding on it's like 2 boxes on wheels.
Uh-huh.
It's like one of them is moving and it hits the other one.
Uh-huh.
That's contact force. When
Uh-huh.
this one's not moving, it gives that one some, so that's contact force.
Okay. And it's when they touch that it happens?
Yeah.
Okay. Okay.
Friction is something like sliding,
Mhm.
like this.
Okay. And what does it do to the thing that's moving?
It slows it down
Okay. Why does it slow it down?
because there's a bunch of little tiny bumps that you can't see on stuff that
Uh-huh.
slows the thing down.
Uh-huh. What happens to the energy in the moving object?
It goes into the ground, or the thing
It gets absorbed, yeah.
gets absorbed by the thing that it's on.
That it's friction with. Okay.
Yeah.
All right. And the next one?
Electric force,
Mhm.
which is
How does electricity work?
it's
Say you have a circuit of a wire that's in a circle.
yeah,
What moves around that circuit?
electricity,
What specifically?
light, or
Not light.
no,
It's a little part of an atom.
a thing.
Electrons.
Yeah, that's what it was. I knew it was a thing, but I forgot what name it was called.
The electrons move around. Uh-huh.
And so,
How does that make energy?
because it can be used to like power a motor, which
Mhm.
makes it move.
Mm-hmm.
That's
If they're moving, they create electric force
yeah.
by moving around the thing. So
Yeah.
they can, if there's resistance, it creates heat or light,
Yeah.
and that's how we can use electricity.
That's why that's also how like if you have one piece of wire and like a battery,
Yeah.
if you tape one end to one side
Yeah.
and then tape the other end to the other side, it'll
Uh-huh.
get really hot.
Yeah. Because those electrons are having resistance in the wire.
Yeah.
That's why light bulb work is because the filament inside the light bulb is very small and it gives resistance and friction to the electrons.
Yeah.
And so they have to slow down and they heat up and light up
Yeah.
and they glow.
Yeah.
Okay.
Magnetic force.
Magnetic force.
So when, like, let's say you have one magnet here,
Okay.
and if this side is north and this side is north on this one, then when you move it close, it'll
Yeah.
go like,
Oh.
it'll go
So on
like,
magnets, do opposites attract or repel?
opposites, like an opposite is south and north.
Okay.
They go like
So is that attracting or repelling?
attracting.
Attracting.
But north and north or south and south go like,
And how can that be used? What's some way that somebody's used that?
with a maglev train.
Yeah, tell me about a maglev train.
Because it's like this part is the train part, and then there's rails which are made out of magnets,
Okay.
and the top side is north, and the bottom of these magnets on the train are north.
Okay.
And and how it moves is the ones on the train,
Yeah.
they tilt slightly, so it goes like do instead of do. So it goes like
Okay, so it makes the train move.
yeah, and it can go faster because it doesn't have friction.
Okay.
It's just in the air.
Wow. Cool.
Yeah.
Okay.
There's those ones.
Okay.
Now the states of matter.
States of matter.
Solid is like ice where it's hard.
Okay. What happens to a shape in a solid?
It doesn't change unless you melt it
Okay.
or crack it or something.
Okay. So it holds its own shape.
It holds its own shape.
Okay.
But when it's a liquid, if let's say you have a tall skinny cup,
Okay.
it's like a big tall cylinder then. But if you pour it into a wide round cup, it's shorter. It's a different shape.
Okay.
And liquids and gas are called fluids because they can change into different shapes.
Okay. And tell me about gas.
And gas is it's air basically, and if it gets hot, it gets bigger.
Okay. Air is a gas, yes.
Yeah. Yeah.
Tell me about the molecules moving.
Yeah. So like with ice, they go like.
Okay, not moving very much.
With water, they go to.
Okay.
But with gas, they're like.
Okay. Okay.
Yeah.
Good. Last one.
Yeah. Sources of power. Muscles is like is when you like move your arm, your muscles are making power to move it.
Where do they get their energy from?
Oxygen and food.
Okay.
And the next one,
Uh-huh.
wind is like when like wind blows,
Yeah.
goes it can turn like a propeller thing to make power.
Okay. What's the propeller thing called? Do you remember?
A wind turbine.
Yeah.
Cody calls them spinnies.
Spinnies. And what makes wind blow?
A thing with clouds and like
A
cold
thing.
front
What thing? A cold front?
and a warm front. Or-
When a cold front and a warm front meet each other
Yeah,
and the
it goes
temperature
like-
changes? And why does that make the air move? It changes the air pressure
Yeah.
and causes it to move.
Yeah.
Okay?
Air pressure.
Air pressure.
Yeah. Like
Okay.
if you go really deep underwater, there's more and more and more pressure.
Right. That's water pressure.
Yeah, that's water pressure.
Okay? Another source of power?
Water. It's like with a water wheel on like a waterfall. It goes like water is coming here, and it goes like
Okay.
and it keeps.
Which way does water flow?
If you're close enough to the Pacific Ocean, it flows west. Well, if you're on the west.
Okay.
It flows west towards the